As discussed earlier, when coal is burnt, there will be conversion of stored chemical energy to heat or thermal energy. But how will you calculate the energy changes in a reaction? Well, in this video, we will explain experimental measurement of internal energy and enthalpy. The energy changes associated with any chemical or physical processes are measured by an experimental technique called calorimetry, and this process is carried out in a vessel called calorimeter. These measurements can be made either at constant volume or at constant pressure. Recall, QV is equal to delta U and QP is equal to delta H. Let us see in detail how the calorimeter works. The experimental technique of the calorimeter involves two steps. Firstly, the determination of the heat capacity of a calorimeter. Secondly, to measure the change in temperature at the completion of the reaction. Let us start our discussion with the measurement of change in internal energy. Here, we measure the heat at constant volume in an instrument called the bomb calorimeter. The whole apparatus is insulated. So, no heat enters or leaves the system, meaning it is adiabatic. Now, see the experimental setup of a bomb calorimeter. The apparatus consists of a steel vessel immersed in a water bath. Here, the water bath is to ensure that no heat is lost to the surroundings. Firstly, place the sample of known mass in a sample cup. Then, the sample is ignited electrically in the presence of oxygen. The heat evolved during this reaction is transferred to the water, and this increase in temperature is measured using a thermometer. This temperature change can be converted to QV by using the known heat capacity of the calorimeter with the help of equation QV is equal to CV delta T. Note, here the calorimeter is sealed, hence the energy change measured would be at constant volume. Now tell me, how will you measure the heat capacity of a calorimeter? Well, you have to measure it experimentally. You have to separately ignite a known amount of sample whose heat of combustion is already known in the same calorimeter. And by the equation CV is equal to C into M, the heat capacity of the calorimeter is determined. Note, here the calorimeter is sealed. Hence, the energy change measured would be at constant volume. As the combustion is at constant volume, here no work would be done. Next, let us discuss the measurement of heat change at constant pressure QP, that is delta H. Heat change at constant pressure is measured using a coffee cup calorimeter. These calorimeters can measure heat changes at constant atmospheric pressure. The apparatus is a formed polystyrene cup partially filled with a known volume of water. The apparatus is also fitted with a thermometer to measure the change in temperature. Here, the heat flow can be measured using the equation QP is equal to specific heat into M into delta T. Note, when heat is evolved or absorbed at constant pressure, there we are measuring the enthalpy. Recall that for an exothermic reaction, heat is evolved and the system loses heat to the surroundings. Therefore, QP will be negative. Similarly, in an endothermic reaction, heat is absorbed, QP is positive and enthalpy of the reaction will be positive. So, we have learnt about various state functions and thermodynamic properties. Before proceeding to more details of such properties, I would like to bring your attention to categorization of these properties. That is, extensive and intensive properties. Extensive properties are those whose value depends on the quantity or size of matter present in the system, whereas those properties which do not depend on the quantity or size of matter present are known as intensive properties. For example, mass, volume, internal energy, enthalpy, heat capacity, etc. are extensive properties, while temperature, density, pressure, etc. are intensive properties. Here we have learned the experimental measurement of enthalpy and internal energy change. Next, consider melting of ice. Can you measure the enthalpy change accompanying the conversion of ice to water? We will discuss this in our next video. Now, let us summarize what we have learnt.
Manorama Horizon. Learning made simple.